This video lesson is going to talk about short-circuiting as it relates to Java programming. Now, oftentimes when I hear short-circuiting, it makes me think of the film from 1986 with a robot that gets hit by lightning and comes to life. But that is not what we're going to be talking about. No robots coming to life. If you've never seen it, it's kind of a cute movie. All right, so short-circuiting happens in two cases in Java programming. One of those cases is where we have A and B, and we know that A is false. If A is false, then no matter what B is, we know what the answer is going to be. We could have false and true, which evaluates to false, or we could have false and false, which also evaluates to false. And since we already know the outcome after the very first one, Java never evaluates the statement. You might think of it being lazy like a teenager, not wanting to do any more work than it has to, since as soon as we know the first one, we know it's false. Similarly, we can have the same sort of case if we're talking about A or B. And in this case, short-circuiting occurs when A is true, because we can see that if A is true and B is false, we're going to get true. And A is true and B is true, we're also going to get true. So in the same way, we already know that it's going to evaluate to true, so Java does not evaluate B. Now, sometimes you might see a problem like this, which kind of looks scary, and you're thinking, oh my goodness, what kind of truth table am I going to have to make? Until you recognize that we've got this and all of this, and that's just one statement with an or. And if you were told if A is true, then we know the entire statement is true by short-circuiting. It doesn't matter what happens to the rest of it due to short-circuiting. Now, if A is false, well, then all bets are off. You got a lot of work to do. You won't be asked to do anything that complex with A being false. Now, the other place where it really comes in handy is a situation like this. Let's say we had some situation where we had some variable n, and we were checking if n does not equal 0, and, so I'm using some Java notation, and I don't know, sum divided by n is greater than 1. Let's say we had some code like this. One of the things that can give you the biggest problems is divide by 0 errors. So a divide by 0, it's called a runtime error, and runtime errors are bad because a runtime error crashes your program. So you don't ever want to divide by 0. Now what's nice is by writing it this way, the first thing we check is to see if n was 0. If n equals 0, this first part is false. And since in an AND statement, it's going to short circuit. So if false, short circuits, and it never divides by 0. So it short circuits, doesn't divide by 0, and then we save our program from crashing. So that's one way that it's used in a very useful format.